Now f of x is given to be from 1 to x ln t by 1 plus t dt for all x being positive real numbers, and another function g of x is given as f of x plus f of 1 by x. And which of the following statements for g of x be true? It decreases or increases in what domain? So before we proceed further, first let us identify the function g of x. As f of x is given to be from 1 to x ln t by 1 plus t dt. Now using this f of x, can we define f of 1 by x so that we can get the function of g of x? Yes, f of 1 by x would now become integral 1 to 1 by x ln t by 1 plus t dt. Now as you observe, f of x and f of 1 by x, only the upper limits are changing. So in order to evaluate the second integral, that is f of 1 by x, we will follow a substitution. Let us put t as 1 by u. Then dt value would be minus 1 by u square du. And why did we do this substitution? As t tends to 1, you will observe that the lower limit u will still tend to 1 only. As t tends to 1 by x for the upper limit, the value of u would become x. And let us replace this and write the new expression for this. Then it is 1 to x, yes, ln of 1 by u by 1 plus 1 by u times dt will be now replaced by minus 1 by u square du. Now what is this integral if you observe? This is integral 1 to x. Ln 1 by u is minus ln u. That minus would again cancel with the minus sign here. And you are left with ln u by u plus 1 into u du. Now, as the definite integral is independent of the variable of integration and we are having f of x defined in terms of t, can we rewrite this in terms of t as integral 1 to x ln t by t times 1 plus t dt? So we got f of 1 by x function also in terms of t. So that the limits are from 1 to x and 1 to x, then only the addition of these integrals is possible. Now once we have f of x and f of 1 by x, let's proceed to find the function g of x. This is given to be f of x plus f of 1 by x, and we have both the functional values. This is integral 1 to x ln t by 1 plus t dt plus integral 1 to x having the same limits. This is ln t by t times 1 plus t dt. Now as you have both the integrals between the same limits, that can be now be expressed as integral 1 to x ln t by 1 plus t common, and from the first integral it is 1 remaining, and from the second integral it is 1 by t remaining. So which on simplification is nothing but 1 by integral 1 to x ln t by t dt. But this is an easily integrable function. What is ln t by t's integral between 1 to x? Yes, this would be half times ln x whole square minus ln 1, that is 0. So we got the function g of x clearly. Once we have the function g of x as half times ln x whole square, can we identify the monotonic character of g of x? That would be easily obtained by the derivative of g of x. So what is g dash x now? G dash x would become 1 by 2 into 2 times ln x into 1 by x, that is nothing but ln x by x. Now, when will be g dash x greater than 0 and when will be g dash x less than 0? If you observe, the sign convention for g dash x is positive if ln x is positive, as the denominator x is always positive as x belongs to R plus. Therefore, this positiveness would depend on ln x being positive. When will be ln x positive? If x belongs to 1 to infinity, and the derivative would be negative if ln x is negative. That is possible if x lies between 0 and 1, right? So g dash x is positive if x belongs to 1 to infinity. Hence, shall we conclude that g of x is increasing on 1 to infinity and decreasing on 0 to 1. Let us observe which of the options are satisfying the character of g of x. G of x is decreasing from 0 to 1. So option A is false. G of x decreases on 1 to infinity. Option D is also false. G of x is increasing on 0 to infinity, but actually what we got is 1 to infinity. So C is also false. So the only true statement is G of x increases in 1 to infinity is the true statement, right?